Today we're going to look at rational and irrational numbers. But first we're going to explore rational numbers. How can I convert rational numbers into a decimal? The first thing you would need to do is use long division. Divide the numerator by the denominator. Now, if the decimal terminates or it repeats, you have a rational number. A terminating decimal ends. It does not go on forever. For example, we would have 1/2 converted into decimal would be 0.5. 3/4 would be 0.75. It terminates, does not go on forever. Another example, 3/5, 0.6, and 1/8, 0.125. A repeating decimal, on the other hand, ends with a repeating number, or you may see a pattern of digits. A bar notation is placed above the digit or the digits that repeats. For example, we have 2/9, 0.222, and so forth, repeating, so my bar notation goes above my 2. Another example, 2/11, I have 0.18, 18, 18, and so forth, and my bar notation goes above my 1 and my 8. Because those are the repeating digits. Hope that's making sense. Terminating or repeating. So my fraction is 7/33. First we're going to do long division. 7/33. So my top dog goes in the doghouse. So my top dog is my numerator and my denominator sits outside. So is it repeating or terminating? It's repeating. Let's look at another example. Terminating or repeating. Example 2. It's terminating. If you look at the very bottom where it's 0 out, shows that my number ended. So my decimal is 0.625. Terminated. Irrational numbers. How can I convert irrational numbers into a decimal? You would use the same procedure that you did. You're going to use long division. Now, on the other hand, when you divide the numerator by the denominator, if the decimal continues forever, you have an irrational number. So let's take a look. Irrational numbers correspond to non-repeating decimals. Can you guess the world's famous irrational number? If you say pi, you are correct. Blueberry pie. Famous irrational numbers. We have a couple examples. This is just a few that I found. Egyptian, the Greek, Hindu, the Roman, and the Chinese. These are all famous irrational numbers. Irrational number. Here's our example, 22/7. This is the fraction form for pi, and if you take a look, you can tell it is non-repeating. None of my numbers are repeating. 3.1428, and so forth and so forth. And it's a number that's going to go on forever. Here's another example. Once again, there's no pattern. My number is going on forever. Now it's your turn. What decimal is the equivalent of 611? If you say A, you're correct. Rational or irrational? If you say rational, you're correct. Rational or irrational? The square root of 27. Think about what we just covered. Okay, perfect square, non-perfect square. It's irrational. It's not a perfect square. Rational or irrational? 0.121212. I see a pattern. So it's rational. It's repeating. Rational or irrational? 5 pi. It's irrational because pi, it goes on forever. It's never ending. All right, here's a summary. So let's see if we can match the corresponding vocabulary. Rational, what did you say? Hope you said a number expressed as a fraction. Irrational, a number that cannot be expressed as a fraction. Repeating decimal, a decimal that ends with the same pattern or number. Terminating decimal, a number that ends. Rational and irrational, they make up the real number system. All the numbers on your number line. Hope that makes sense. Remember, you can always pause the video, rewind, rewatch as many times as you like.